Hey guys, today we're going to go over 9.5 conditional probability independence, as well as going over some of those probability terms that we saw on Monday. So I just kind of started by filling out this table. I've got 12 boys, 16 girls, 4 boys, and 5 girls were wearing white shirts. That means that there's 8 boys and 11 girls not wearing a white shirt, for a total of 19 total kids not wearing a white shirt. So if a student was chosen at random from Mr. Mabry's class, what is the probability of choosing a boy or a student wearing a white shirt? So for these probabilities, we're choosing a boy. How many total boys do you see? Well, I see 12 out of 28 total students in the class. And or means I'm going to add the probability of students wearing a white shirt, which is going to be 9 out of 28. But what has happened is I've added a value twice. Do you see how the 4 is circled twice? So if the 4 is circled twice, I've got to subtract that out because I only want to count it one time. So then I'm just adding 12 plus 9 minus 4, which is going to be 17 out of 28. And I'm totally fine with you leaving these fractions unsimplified. 17 over 28 doesn't simplify regardless, but if you were to be able to simplify it, you can leave it just like that. So if a boy is chosen at random, what is the probability he wore a white shirt? So let me read B real quick. If a student is chosen at random from Mr. Mabry's class, what's the probability of choosing a girl who is not wearing a white shirt? So if it is who is not wearing a white shirt, that sets something called a condition. That tells me that out of the people who are not wearing a white shirt, what's the probability that they're going to be a girl? So out of the people not wearing a white shirt, there's 19 total. How many girls do you see? So that's 11 out of 19. So a condition is going to change the denominator so that you're looking at a different group of people when you're calculating the probability. If a boy is chosen, now the condition is that it has to be a boy. If a boy is chosen, what's the probability that he wore a white shirt? So out of 12 boys, the probability that he wore a white shirt is 4 out of 12. If the student, let's see if I can erase some of these lines, kind of simplify it a little bit. Whee! Okay. If the person chosen, if a student with a white shirt is chosen, so the condition is that they have to have a white shirt on. What is the probability? It was a boy, so out of all the 9 people with a white shirt, there are 4 boys. What is different about the answers in part C and in part D? Well, in part C, the condition was that it had to be a boy. In part D, so in part C, condition was from the group of boys. In part D, the condition was from the group of students who wore white shirts. So without knowing, you actually have already learned conditional probability. When I set a condition, it changes the denominator. All other times, you're going to use the main total as your, like the 28 students for the denominator like we did in question A. But if I say, okay, now it has to be from the group of boys, now it has to be from the group of people wearing white shirts, that's going to set a new condition which changes the denominator. So that's called conditional probability. I keep saying it sets a condition, but we also can use this given word. So anytime you see given in your phrasing, that's going to be an indication that it's going to be conditional probability. So the way that we notate it is this P, W, bar, B, but I read it as probability of wearing a white shirt given, so that little line right there, that represents given, they were a boy. So it's the probability. So part D, it says, what's the probability it was a boy given they wore a white shirt? So the probability of a boy given they were wearing a white shirt. Okay, So the given condition is always going to be the second term that you're using. So then that means that I'm going to say probability of a boy given white shirt.